Hello. So now this will be the first video in this section on absolute value equations where we talk about how to solve algebraic absolute value equations. Now, I know we've already seen this example in particular, and we already know the solutions are x equals 3 and x equals negative 3, okay? But the purpose behind us doing this example right now is because I'm going to show you the systematic way I think about these problems. And in this simple example, it'll be very clear. And then when we look at it in more complicated examples, that'll make more sense. Okay, so let's start here. So the basic idea is this. We recall that the absolute value of x in our analytic definition is either x itself if the input x is positive or 0, or it's the opposite of x if x is negative, right? In other words, when we're looking at a problem like this, at a absolute value equation like this, there's two possibilities. Either x is already equal to 3, right? If it's already if x is positive, we can just remove the absolute value. Or what if the inside is negative? Then we take its opposite, right? Okay. So let me recap what I'm talking about here. Either the inside is already positive, in which case we just pull it out, right? So that's why this came out here in this case, right? This is the case that x is bigger than or equal to 0, or the inside is negative, in which case what comes out of the absolute value? The opposite of x. So that's like this, right? And so if you look at this, if I have x equals 3, well, that's already solved. So that's one solution. What if I have the opposite of x is equal to 3? Well, we know that to get the x by itself in this scenario, I have to divide by negative 1. I have to divide by negative 1. This becomes positive x. And then this, 3 divided by negative 1, that's negative 3. Okay? Okay. And again, here we have our solutions as we had gotten before. Before we had gotten it from just the fact that they're small numbers and it's very easy to see what the solution is. But here I wanted to show you the systematic technique that we're now going to apply to several more interesting examples. Thank you, and I'll see you soon.